Net Ionic Equation. Today we are going to study about how to write net ionic equations. The different steps to do the or write down net ionic equation are the following. Identify the cation and the anion. Combine the cation from the first reactant with the anion of the second to get the first product. Combine the anion from the first reactant with the cation of the second to get the second product. Balance the equation. Determine whether the products are aqueous or solid by consulting the solubility chart. That means you have to see into the solubility chart to see whether the substances are soluble in water or insoluble in water, partially soluble in water, and compounds which do not exist on or decomposition in water. So what I mean over here is substances which are soluble or will be aqueous solution, and substances which are insoluble will come under solid substances. Then next point, write the total ionic equation. Cross out the spectator ions. And finally, we'll write down the net ionic equation. So let us understand how to write down the net ionic equation with the help of an example. Now we have two compounds, KCl plus lead nitrate. So the first thing that we have to do is identify the cation and anion. So here we can see K is the, we can just write down on the top K plus and Cl minus. So K is the cation, and that is potassium is the cation and chlorine is the anion. And in the second compound, lead is the cation and nitrate is the anion. It's a we can say is a polyatomic ion. So instead of anion, we can also say it comes under anion only. So it's a polyatomic anion, that is NO3 2. So now we have to combine the cation from the first reactant with the anion of the second to get the first product. So let us do that. So here cation from the first reactant, so K, that's the first one, and the anion of the second, so KNO3. So that's the first product. Now the second product. Combine the anion from the first reactant with the cation of the second reactant. So we'll see lead PbCl2. So this is how we write down the products. One is potassium nitrate and the other one is lead chloride. Now balance the equation. So let's balance the equation. So if we see potassium over there, the chlorine over there, here we have 2 chlorine, there we have 1 chlorine, and then also we see potassium, then the potassium will change, it will come to 2 potassium. So let's write that down. So 2 KCl plus PbNO3 whole 2 will give you 2 KNO3 plus PbCl2. Now we have to identify the solubility of each compound with the help of the table. So if we look at KCl, it is soluble. So we can write down 2 KCl and we can write down aqueous over there. How do we find out? When we look at the table, we can see potassium over here and we can see chloride ion. Where's the chloride? Here is chloride. So when we compare it in the table, they are soluble, so aqueous. Plus then we come to lead nitrate. Again, if we refer to the table, we have lead over here, and then we have nitrate over here. So again, it comes under solubility, soluble. So PbNO3 whole 2, and we can write AQ over here. Let's go to 2KNO. So even potassium nitrate 2KNO3 is soluble, so we can write down aqueous. Now when we come to lead chloride, so if you look at the table, lead over here and chloride over there, here is, that's lead chloride, so lead and chlorine over there. So exception over there, when chlorine combines with lead combines with chlorine, then there is an exception. So we can see over here it's not soluble, so it's a solid. So we can write down PbCl2, and we can write down solid over there. Now let's move on to the next part, that is, let's write down the total ionic equation. So let's write down the total ionic equation. So 2K plus, we can write down AQ over here, then 2Cl minus, again over here we can write down AQ, plus Pb2 plus AQ, and then since there is a 2 in nitrate, we can write it in the front, 2NO3 minus AQ, and then the product side 2K plus, that's again an AQ, and then nitrate is 2NO3 minus, that's an AQ, and then we can write down PbCl2, and that's the solid. So now we have finished writing the total ionic equation. Now let's move on to write down the net ionic equation. But before we write down the net ionic equation, we should be aware of crossing out the spectator ions. What are spectator ions? Spectator ions will be common in both the side, and they have not changed from the reactant to the product. So we will see the spectator ion potassium on the reactant side and potassium on the product side. Then we look at nitrate in the reactant side and the nitrate in the product side. Now let's write down the final net equation. So we have 2Cl minus, then we have Pb2 plus, and then we have the product, that is PbCl2. So let's write the net ionic equation. Net ionic equation. So what will that be? 2Cl minus plus, and not to forgetting AQ, because it's aqueous, Pb2 plus, again over here aqueous, will give you PbCl2, and this is this insoluble substance which we write as solid. So finally the net ionic equation is this one. Now let's do another example so that we get used to writing the net ionic equation. Now in the second example, we have magnesium chloride MgCl2, and the other reactant is silver nitrate AgNO3. 3. So the first step that we are going to do is identify the cation and anion. So when we identify the cation and anion, we'll be able to write down the product. So here and also combine the cation from the first reactant with the anion of the second. So we'll see the cation is here and it will combine with, let it combine here with nitrate. So magnesium will combine with nitrate and magnesium is Mg2 plus and nitrate is NO3 minus. So that's the cation and the anion. And in the other one, Ag and chloride. So if we look carefully, we'll see chlorine is 1 chlorine here and 2 chlorine here. So we can balance the chlorine first. So let's write down MgCl2 plus AgNO3 will give you MgNO3 whole 2 plus, here we can balance 2AgCl. Now when we balance 2AgCl, then we'll see that the other side, the reactant side, Ag also we can write a 2O here. So we have balanced the silver nitrate also. So chlorine is also balanced and silver nitrate is also balanced. Now the next step is determine whether the products are aqueous or solid by consulting the solubility chart. So naturally, when we consult the solubility chart on this page, we'll be able to find out which substances are soluble, which are insoluble. So soluble will naturally be aqueous and insoluble will be partially soluble, insoluble, or soluble will be solid. So let's write it down. So MgCl2 and we can write down aqueous plus 2AgNO3. This is also aqueous. If you look into the chart, will give you magnesium nitrate. This is also soluble. But when we look at AgCl, Ag is here and Cl is here, we'll see that it is insoluble, the pink one, insoluble in water. So clearly shows us insoluble in water. So 2AgCl is a solid over there. So that's the solid. Now the next step is write the total ionic equation. So what we have to do is total, T-O-T-A-L, total ionic equation, E-Q-U-A-T-I-O-N. So let's write down the total ionic equation. Mg will be 2 plus and that's aqueous, plus chlorine we write down 2, Cl minus, that's again aqueous, plus 2Ag plus over there we can, and then we have plus 2NO3 minus, that's aqueous, will give you Mg2 plus, that's aqueous, AQ, and then plus 2NO3 minus, this is again aqueous, plus AgCl, and that's solid over there. So most of all of them are aqueous, so we have written it. Now next step is cross out the spectator ions. So eliminate the spectator ions. So who are the spectator ions? The ones which are in both the side and which have not changed from the reactant to the product. They are just not involved in the reaction, they're just there, so we can get rid of it. So the first one is Mg2 plus in the reactant side and Mg2 plus in the product side. Then we have nitrate in the reactant side and nitrate in the product side. So we have got rid of the spectator ions. Now the last step final step is net ionic equation. So let's write that down. So it will be 2Cl minus plus 2Ag plus, and then we have 2AgCl. So if we write down the aqueous, AQ and solid over here. So it's clear, both the side it's clear, and this is your final ionic equation. 2Ag 2Cl minus, those are aqueous, and it gives you AgCl. So this is the net ionic equation. So it's completely balanced and clear. I hope you all have understood how to write the net ionic equation, and you have understood the term spectator ions. So I hope you like this video lesson, and you can share it with your friends, and please subscribe for the channel if you have not subscribed. Thank you, students.